Cool. All right, cool. Good evening, everyone. Welcome to our second webinar of the year. Our first webinar was on 8th of January, where we discussed a lot about, about planning for my data this year, your feedback, your suggestion, your recommendation, and whatnot. Thank you so much for that. So today, we have a more technical event plus a chit-chat event. I will just talk about our speaker, introduce him for a while. Hussein Zulkifli, founder and chief technical officer of his own startup, Mesolithica Hyderabad. He's a software engineer specializing in big data pipelines, real-time processing, and NLP, natural language processing. And maybe some of you know, and some of you might be the first time of hearing this. He is the creator and maintainer of Malaya, Bahasa Malaysia Natural Language Toolkit library, and it's powered by deep learning TensorFlow framework. You can actually Google about it. The GitHub or the documentation page is super easy to find. It's quite a popular library in my opinion. So, hi, Zulkifli. I'll pass the floor to you, and let's get started on the sharing.
Thank you. Share screen. Share just Google Chrome. Oh. Hello, my name is Hussein Zulkifli. I'm going to explain the library I created. I call it Malaya-Speech. If you want to go to the original documentation, you can click that link, or you can type it in that link, malaya.readthedocs.io. So what is Malaya-Speech? Actually, it's a toolkit speech library for Bahasa Malaysia or Malay language. It's powered by deep learning TensorFlow. So speech toolkit means that we have many solutions to solve waveforms problems in one library, and we're going to get things done very fast, just pip install and everything good to go. And Malaya-Speech use very less dependencies. We just use TensorFlow, Librosa, which is a common library to do audio processing, and NumPy. That's all. Deep learning, so with the state-of-art approximate universal function, which is neural network. So we can solve most of, I think partially solve most of speech problem. And then right now we use TensorFlow because I have experience in TensorFlow, and the good thing, if you use TensorFlow, you can get a lot of access to Google resource like a TPU. I use TPU for almost 2 years for free right now to train my models in Malaya-Speech and Malaya. TPU is very expensive, $8 per hour. So do we need a speech toolkit for Malay, right? So we know the sole purpose of NLP to reduce the gap between human interaction and human and machine interaction, which is to improve the HCI, human-computer interaction, right? So most of the time we heard about text-based analytics, sentiment analysis from the text, emotion, translation, and so much more. And a lot of sci-fi movies like Jarvis from Iron Man. So it's very good speech system actually. It can understand emotion. You can understand gender, which is, which one is Miss Spot, or which one is Mr. Stark. And then it knows to translate to text, from text, and try to analyze what kind of entities that Miss Spot or Mr. Tony Stark going to say the entities related, and text to speech back what trying to respond to the users, right? So we know typing is very slow. We as human, we have a very huge bottlenecks process, from what we think, from what we thought, and then we try to put into a sentence structure, and later then the hand coordinations. So according to Ethnologue 18th edition, Malay is the 9th most spoken language in the world, with 77 million native speakers and 173 speakers. second generation. So Malay is a national language Malaysia, Singapore, Indonesia, okay, and Brunei. So here we want to build a smarter human computer interaction specific for Malaysian. So why we open source this toolkit? We want the users able to use by simply plug and play, even you are not the expert domain, which is you know how to solve the problem, but you don't have the tool to solve the problem, right? So we want to build a kind of library users can install, developers can install and try to solve their problems, speech to text to speech, and so much more. All right. So this is time versus hype. During the time goes forward, the hype is going up, right? We watch a lot of Iron Man. Oh, that sounds cool. We have the speech to text and text to speech system is very nice. It's very powerful. Java is so cool. Okay, but in the real world, it's very complicated. Require multiple modules to put into in single software. But when nobody can deliver, investment burns out. So this is common timeline for winter AI. And usually this thing restored by initial libraries, and then this library can fail. And usually this library, the big companies we try to improve, like PyTorch, Facebook try to improve together. Google try to bring TensorFlow forward, and so much more. And for my hand, I already have I have already a library called Malaya. So it's really good on classification and then understanding and generation. So we can combine those, right? This library, which is this really good with speech synthesis, speech understanding, and vocoding. So we combine it, boom, you are the very nice combinations. Huh? My slides, that's all actually. So I'm going to show, to demo what Malaya-Speech can do. Okay. So this is the original documentation for Malaya-Speech. We serve under Read the Docs. Anyone can push documentation to read docs actually. It's a toolkit for Bahasa Malaysia. To install it is very simple. If you have CPU version, you can just install Malaya-Speech. If you have a GPU, you want to utilize the GPU, first GPU, second GPU, and so much more, you can install Malaya-Speech GPU. And right now we only support 3.6 and above. So we use some syntax that only 3.6 above can understand. And TensorFlow 1.15 and above, including TensorFlow 2. Malaya-Speech can detect age from the speech. Diarization. Diarization means that if I have two speakers overlap each other, so it knows which timestamp for the first speaker when to talk, and the second speaker going to talk. Emotion detection from the speech, gender detection, language detection, noise reduction, speaker change when the speaker change from speaker A to speaker B, speaker overlap when the timestamp the speakers A and B or more than two speakers overlap each other. Speaker vector is like word to vec but for speaker, so it know the similarity between my voice and another male voice. So we have a tendency in terms of vector speaking, it has a similar definition. Enhance speech, speech to text, super resolution, text to speech, vocoder, voice activity detection, voice conversion, and then quantization. So actually we try to do a lot of reverse engineering from the papers. And so these are some of the model we created our own architectures, like a light conformer. So this no paper produce. We try to compress the size of conformer. We call it a light conformer. And we also have our own voice conversion. So we use a transformer to solve a voice conversion problem. Later we can go as a voice conversion. Speech to, so we're going to look into the first definition. When we look into speech toolkit, right, we want speech synthesis. So we look into vocoder. Where I put vocoder? So the vocoder means if I have a MEL spectrogram, I want to convert from MEL spectrogram to waveform. So this is the traditional way. We don't have this kind of method, right? Because when you change your waveform into MEL spectrogram, you lost a lot of data, which is a complex definition of your spectrogram frequency domain, right? And MEL spectrogram, you already compress between two certain size of the dimension, right? To reverse it to become a waveform is very complicated. The old method is not really good. But we follow the paper called Melgan. It's pretty good. And then we have a single speaker Melgan, like male, female, me, and Hakim. And we also have a universal vocoder, means that if we give any MEL spectrogram, it can reverse the waveform, any MEL spectrogram. So the universal Melgan is a quite new paper, I think around November or October 2020. So this is, for me, this is very groundbreaking, because if you able to reverse any MEL spectrogram to waveform, you can solve a lot of speech problem, because most of speech model right now, it try to synthesize from the waveform. So if you look into waveform data, which is 1D, it's very long. Most of it duplicate each other, right? Let's say we have a sample rate 44,000, right? So that is very long of data. Even most of the data overlap each other. So the good thing when we convert into and then we can, most of machine learning models try to convert from waveform to MEL spectrogram or spectrogram, because we change it to frequency domain, and that's what we want. And then when we change it to frequency domain, the timestamp become much more smaller, and then we have a definition in terms of another dimension, which is frequency. And the definition of MEL spectrogram, which is we heard about the sound from what, a whale, right? Sounds like whale. So actually that sound is not actually come from the whale. So that sound is normalized by the MEL spectrogram. The whale doesn't sound like that. To use to use this Melgan or vocoder, you can just import Malaya-Speech, and then you try to follow. You try to follow what which model you want to use it. Is it female? Is it male? Is it Hussein? Is it Hakim? And you got it. It's very simple. You just put like this, and then you give some example in terms of male, and then it's able to reverse the male, able to convert MEL spectrogram into waveform.
Kenapa kau selalu suka menuduh-nuduh aku saja bila ada sebarang kejadian yang tak baik, ha?
So this is the original waveform. So this is we try to convert MEL spectrogram into audio.
Kenapa kau selalu suka menuduh-nuduh aku saja bila ada sebarang kejadian yang tak baik, ha?
Yeah, it's pretty nice. The reason why we need vocoder, let's say we have a text-to-speech model, example for fast speech. So most of text-to-speech model are going to convert into MEL spectrogram. So we need a synthesizer that able to convert MEL spectrogram to waveform, because MEL spectrogram is just a frequency domain, right? So we're going to convert into the original 1D data. Fast speech or any text-to-speech model is going to generate spectrogram or MEL spectrogram. But most of the current models, speech-to-text, state-of-art, they generate MEL spectrogram. And we have very specific MEL spectrogram generated with feature size 80. And then you need to use Malaya-Speech vocoder to convert MEL spectrogram to waveform. And then this model can generate more longer than 2000 timestamp of male spectrogram. It will show error because fast speech based on transformer, we have maximum duration they're able to do for the attention size. So if you're going to load, we have how many models here? 7 models, male versus version 2, female version 2, me, Hussein version 2. So the version 2 is just another smaller model. If you look into this, if you're going to load it, just simple like this, Malaya-Speech, TTS, fast speech 2, and then you got a male. If you want to use a quantize, you just quantize equal to true. Quantize is much more smaller. You can see that. Just 51 megabyte, and you cannot see the difference. For example, if we're going to generate, what's the text for this? The example text is what? Syed Saddiq berkata mereka seharusnya mengingati bahawa semasa menjadi Perdana Menteri Pakatan Harapan. Right? So this is the original without the original male model.
Syed Saddiq berkata mereka seharusnya mengingati bahawa semasa menjadi Perdana Menteri Pakatan Harapan.
So this is quantized model.
Syed Saddiq berkata mereka seharusnya mengingati bahawa semasa menjadi Perdana Menteri Pakatan Harapan.
You cannot see the difference. Right. So the good thing about fast speech, you can play around with the speed, right? You want to make it slower, you can.
Mereka seharus.
You can try to change the frequency.
Syed Saddiq berkata mereka seharusnya mengingati bahawa semasa menjadi Perdana Menteri Pakatan Harapan.
And you can look into more examples for fast speech. For example, you can look at multi-TS fast speech too. And then if you look into noise reduction, so noise reduction is just a masking model which is come from a UNet. Sorry, my internet is quite slow. So this is the example audio.
Hello, Assalamualaikum.
Right, so you can hear a background noise overlap with the speaker. So we want to reduce the music, right? So you can do that using this model. After that, you're going to generate voice and noise.
Hello.
Can you see that?
Assalamualaikum and welcome to our channel.
It will amplify the voice, and then you also can try to play the noise only. Yeah, this is what we call, this is the noise reduction do. And then we go into a classification model. Let's say H, right? For example, this audio, Singaporean white boy.
Known as actor who can speak.
So in this audio, right, they have multiple speakers, right? We're talking about multiple speakers. We want to detect H for each speakers in the audio. So the good thing about audio detection or audio classification in Malaya-Speech, going to classify multiple speakers at the same time. Example for like this, right? You can see that for the music detected as not an H. After that, you try to assume that the Englishman is a teen, and then after that, going to 40s. Right now, we only provide two different models, which is VGG Box version 2 and Deep Speaker, and it knows when not a voice activity, just a background music, so it detected as not an H. So you just give audio and then you try to do same thing like this. Same goes to emotion. Emotion, you can see that. Same thing. All the classification module for Malaya-Speech can do exactly like this. I know it's quite complicated. and then we try to solve a lot of problems in here. Last example, because my time is limited here, which is speech to text. Sorry, voice conversion. I think speech to text is very straightforward. Voice conversion. Okay. So the definition of voice conversion here, if I give one sample, if I have original voice, right, and then I want to mimic another voice, just give one example. Example, this is my original audio.
Sebagai pembangkang yang matang dan sejahtera, PAS akan menghadapi pilihan raya umum dan tidak menumbang
politics.
kerajaan dari pintu belakang.
So I have a target audio, I think the voice from a
Orang yang
female.
seperti apa?
So I want this female speak the same thing like the original audio. So that's the purpose of voice conversion. So you just follow the step here. You have original audio and then you have a target audio. So the output is,
Sebagai pembangkang yang matang dan sejahtera, PAS akan menghadapi pilihan
Yes.
raya umum dan tidak
Like
menumbang
this.
kerajaan dari pintu belakang.
I'm not sure you guys can hear or not. Can hear or not?
Yeah, we can hear. We can hear.
Oh, thank you so much. If nobody can hear, it means that my presentation is so empty.
No, we hear all the way. And we have so
And
many
here also,
questions.
I have,
In fact, they put her up.
you also can for Malay in English.
They were so astounded
So
to
this
see
is
her.
the
'cause she
original
was-
audio. This is the target audio.
My view has, in fact, we put her up. They were so astounded to see her because she was, I mean, it was one of the cleanest people in the world.
Yep, that's the voice conversion. So right now we only support fast voice conversion. So this is we created our own model for this. I think that's all for me. Any more example you can play around with this documentation. Feel free to ask any question.
Right, please post your questions in the chat box. We'll go through one by one later.
Okay.
Hussein, I got question my own. Can I ask?
Yes.
All right. So I can see that the whole Malaya-Speech library is geared towards like a generative adversarial kind of objective. Am I right?
Correct.
Yeah. So okay, it's amazing, and I can really tell that I can trust if I get some voice recording outside anymore. But in the real life, right? How does your vocoder can be used? Like we don't get the mail. Normally we can just get the recordings, right? Yeah.
So the purpose of vocoder, which is if you have a mail spectrogram, the mail spectrogram is another derivation after a spectrogram, which is a frequency domain, right? When you change into a frequency domain, you lost the definition in terms of 1D signal. You cannot listen to spectrogram, and especially mail spectrogram. The mail spectrogram is much more compressed data in term of data, right? And then the size of if you have a fast Fourier transform, the definition, the dimension of FFT is 512, and then you change it to mail spectrogram, you compress your data to become much more smaller. And then to reverse back from mail spectrogram to do traditionally how we going to change back mail spectrogram to 1D dimension, you convert back to fast Fourier transform FFT, and you convert back into one dimension inverse Fourier transform. If you have the complex angle definition from the frequency domain, if you don't have, you can estimate based on you can estimate the angle by certain size of loop, right? So the traditional way is you can hear it's very broken. It's not very good. So the good thing about mail spectrogram, mail gun, or mail synthesizer, the current model is able to synthesize any mail spectrogram into waveform back, right? And right now we have a universal mail gun. So this is really good. Means that it can convert any mail spectrogram it never seen to original waveform. For example, like this, the original audio is like this. Anti-kata. So this is when you're going to convert back from a male spectrogram, which is male definition, and then generate back to one dimension waveform. So the definition of male spectrogram is you can look into text-to-speech, fast speech. So this is male spectrogram. It doesn't have definition in terms of a sound anymore.
Yep, I might want to interrupt here. So you're saying that if you're using your, what do you call it, vocoder, if you're using a vocoder, the transformation between male and the traditional waveform or the frequency domain waveform that we are seeing, the speed will be faster.
The speed much more faster and much more accurate.
Because there's no like a logic calculation that being applied to every frequency, am I right?
Yeah, something like that.
The conversion will be super fast.
Yeah, correct. The model is very small.
That's
actually.
amazing.
That's the good thing about GAN. we estimate the distribution.
All right, we have another question from the floor. So Eugene Teo asks, do you use any other time frequency representations other than mouse specs? Maybe constant Q transform?
Sorry, what? Q transform?
Can you refer to the chat, or you want me to speak it up? Yeah.
Do you use any other time frequency representation, maybe constant Q transform, etc., or have you identified the male specs are the best representation? Right now, most of the papers use male spectrogram is much more smaller, and most of papers standardize to 80 size of male spectrogram. So we just follow the same thing. In terms of definition of the transformation, I never done any comparison.
Do you answer your questions? All right. Hi, Philip. So do all the participants has the ability to unmute themselves?
Sorry, what?
I think so. Can someone try?
Yep, I think participants, you are able to unmute yourself if you want to ask any questions.
Yeah, correct. Feel free to ask. I know this is very technical. That's the purpose.
It's quite interesting to me because, okay, as a little background of mine, I was researching into seismic. So I was playing around with frequency domain a lot. But yeah, this is the first time actually, because since a long time ago, that I see such an interesting usage. It would be nice if this happened quite a long time ago.
Yeah. Usually mesh spectrogram, we do it for voice because it normalizes into a certain sound.
Yeah, and if we are talking about seismic, we do have something similar, but that's what we call it.
Should be.
It's like a hacky way of velocity profile, something like that.
Correct. Should be.
All right. All right.
Right now, there's very lack in terms of speech toolkit models on the internet. So I try to put into one together into a library to make it people use it very easily. Why
Eugene asked a follow-up question.
Why TensorFlow rather than PyTorch? Actually, most of speech model written in PyTorch, I reverse engineered to put into a TensorFlow. I love frozen graph, the static graph, less memory consumption, and just in time to run the model. That's all. I reverse engineer a lot of papers written in PyTorch, and then it's very tough to reverse engineer and then code it in TensorFlow.
That's amazing. May I ask, like, how many developers working with you at this time?
Right now for Malaya-Speech?
Yeah.
Just me. I do it for fun.
Oh, hi.
Do it for fun, and then yeah, we are contractor for certain agencies. They want to train their own text to speech using their own data and speech to text.
All right. Okay. Thank you so much. Do we have other questions? All right. If you don't have, Hussein, we will just swap the slide back to our PyData if that's all right.
Yep, yeah, sure.
Thank you so
Not
much.
sure.
Oh, sorry. Philip, please go ahead. Philip has some question for you.
Sorry, hi say. Given the current state of, I mean, this is more a general question, right? But given the current state of NLP, right, when we, if we come across, controversial recordings out there, how skeptical should we be that these are legitimate recordings, because some of these sound very, very convincing.
So the question here?
I mean, given the
Philip,
current
you lost
state
a bit just
of, yeah, sorry. So like, given the current state of, say, speech models, right? If another, controversial recording comes up on the internet about some, high-profile figure, how skeptical should we be that this could be generated by a gun?
Steve, to generate by gun, that gun need to train on the single speaker quite a long time and at least 5 hours, a very clean voice. So actually it's pretty hard. Even the voice conversion model right now is not that good.
Okay. Thanks, that's useful.
How well does this work for different variants, dialects of Malays? Right now when we're talking about variants or dialects, right? For speech to text is pretty good because we actually try to do semi-supervised from Google Speech, speech to text from Google, and actually Google pay a lot to annotate our data. They pay 70 Singapore dollar to annotate 1 hour of our data, which is come from most of YouTube. And then our YouTube in Malaysia, we have from Ustad, which is the Ustad from northern Kelantan, from east, and the northern, which is Kedah. So actually, if you try to use the model, Google Speech or our model, it quite okay on Kedah and Kelantan because that's the most common dialects, different dialects on YouTube. If we have more videos on Sabah and Sarawak, and then we try to do semi-supervised, it should be better lah.
Does that answer the question, Eugene?
All I can say, I can I satisfied with if for Kedah and Kelantanese.
That's good. So you were mentioning that the model you are currently having, YouTube Google actually paid you for the annotation service, is it?
Pay me? No. We
you pay
use
them.
yeah. No. We use semi-supervised. Let's say we have audio, right? We have a lot of audio, and then we use Google Speech to text to get the text, and then we fix after that. First, we train the baseline models. After that, we keep iterating to improve it. It's a few steps, but it works.
Got it. All right, cool. So do you have other questions? Do you have another questions?
What AE are your experience transforming speech?
Did you get my question?
What AER?
ARE, sorry, that was typo.
Oh, my experience transforming speech from non-Malay speakers to be more Malay sounding speech. So this is another voice conversions, right? So we're going to follow the tempo. There's a paper recently, they call it auto split. So that split going to split into a tempo, time, and another part of audio. So right now I'm trying to duplicate the same results and then convert it into a transformer base to make it much more faster. Hopefully I can release them. So if you give a non-Malay speaker audio and then you give a Malay speaker, it should maintain the same audio, but it try to follow the Malay sounding from the Malay speaker. The original implementation, they use RNN. I hate recurrent neural network. It's so slow. And then the result is not that accurate. So hopefully we can done in transformer.
Why is speed? Sorry, can I? Why?
Let's go ahead. Let's go ahead.
Is speed really a problem these days? I mean, you can use the cloud. You can use a lot of, GPUs and all that. I know they're expensive. I suppose that's the
reason is because it is very expensive.
Yeah.
If you try to run on your laptop might produce sounds like wow, so noisy.
Yeah, I should buy one of those Bitcoin machines. Maybe that'll help. Thank you.
Yeah.
Thank you too. All right, I guess that's it. Hi, that's it. We're gonna swap back to our slide.
Oh, sure. Stop share.
No worries. Hi, Philip. Can we show our slide again? Our banner. All right, cool. So it's 9:10 p.m. I know some of you voted to have a chit chat session or discussion session in this big room, but right now I can see we have 11. Ideally, I think by chit chatting, I think 5 to 6 people per group per room might be an ideal way to go. Can we actually just break up into two rooms? Is that okay for you guys?
Yeah, I'm good.
How about the participants? Can I hear some answers?
Right now, I also work for Faith. I handle engineering side data. So you also can ask data engineering.
Yeah, the Yvonne we have right now, are you the Yvonne from Faith? Just asking.
Yeah.
All right, Philip, can you go ahead and break us out into two groups?
Okay.
No worries. Oh, shall I do that? All right, cool.
Okay, join breakout room. Thank you. I created the repo August 2022. Malaya, I created 2018, March 12.
Theo, I think you are muted. Sorry, yeah, because when we put everyone in, everyone is by default muted. You can unmute yourself.
Yeah. Okay. No, I heard I asked Hussein how long has he been working on this project, because it looks pretty reasonably mature in terms of the libraries he's got. So it was so we got transferred from the breakout session.
Yep.
Yeah, my apologies for that. Right. So some of us here might be in the other room. Do you have question to some of us here? Like any question or something you want to learn or you want to know about?
Yeah, hi, Hussein. Just curious, like you mentioned you work for Faith. So like, how much time do you commit for like these project or any open source project? Like, what's your schedule like, daily or weekly?
For the morning side or the day side, usually I commit for my job, night side. I commit for my for open source, because this open source actually my company built on top of my open source, which is Methodistica. We got funded because one of the early investor want to create a product based on our library. So they said, Sin, why not you open up Sindang Berhad? We inject some more money lah. So that's how we started. From there, we become a consultant to consult any companies that want to do want to have a commercial support. We can give you the commercial support, and we also can give you a very specific B2B solutions.
All right, cool. Thank you.
One question, Hussein, based on your Malay, what use case have you already put it into practice?
Most of the use case, which is they want to know the sentiment of the products. They have products, they want to know the sentiment, and then what kind of topics that related to bad sentiment. If you sell water, what's the topics that related to the bad sentiment? Is it because the taste is not good, something similar? And then if we also have clients for politic purpose, obviously, so they want to know the sentiment or the political landscape for certain locations. And then if we're going to talk about certain topics, who's the entities related to the topics, and then what kind of sentiment. So if you're going to do some news about the certain locations, so what's the good topics for that location? That's the common products.
Okay, thanks.
Quite commercial directed. Hi, just before we actually end the session tonight, I think because we're running out of time,